Earlier we said we would temporarily remove the check for an I/O error to show off the finally block. However, in practice we would still want to check that while also checking for a type error. So when opening a file, we want to check for an I/O error, but then when reading from the file, we want to check for a value error. And we want the code to react differently based not only on what error is encountered, but on when it's encountered. So this code does that. Specifically, it encloses two try blocks within one another, an inner block and an outer block. The outer block is mostly responsible for trying to open the file and load it into the variable input file. The only thing that can go wrong there is an I/O error. So if that happens, things jump down to the except block on line 18, and it prints that an error was encountered reading from the file. However, if the file is successfully opened, it still wants to run a try block on the contents of the file to see if it can in fact convert every line of the file into an integer. If it fails, it terminates the loop and jumps down to that except block. However, even if it fails, we still want to close the file, and so that's enclosed inside this finally block, because that will run regardless of whether or not an error was encountered. So here we see the results if the file did in fact contain numbers, as you can guess from the file name numberfile.txt. It starts the first try block, tries to open the file, and succeeds, so it doesn't jump down to the except block. So it continues and encounters the next try block. That try block says to run a loop for each line in the file, convert each line into an integer, and then print the integer. As we see over here, there are 5 lines in the file, and each of them did in fact contain an integer, 1, 2, 3, 4, 5. So this loop runs to completion as well. That means the code can skip the except block because no error was encountered. And that also means it runs the else block, since the else block basically says, else if no error was encountered, do this. And so for that reason, we see the print message, no errors occurred converting the file. And finally, we have the finally block, which it runs regardless, and closes the file. Then because there was no trouble opening the file in the first place, it skips the except block corresponding to that first try block, because there was no I/O error. So this is what happens if the file we're trying to load actually does contain all numbers. What if it doesn't though? Here's what happens if our file only contains letters instead of only containing numbers. Again, the code starts the outer try and tries to open the file, and it opens the file just fine. So it continues on to the inner try and tries to run this loop. However, the first time it runs the loop, it encounters an error. The contents of line was not an integer. In fact, if you could see the file, it was just the letter A. It can't convert the letter A to an integer, and so this triggers a value error. That jumps execution down into that except block, where it correctly catches the value error and prints that a value error occurred to our output. Because an error was encountered, it skips the else block, but once again, it runs the finally block regardless and closes the file. And then because there was no error specifically inside the first try block, it skips the except block that corresponded to that try block. Notice that technically the error that occurred on line 8 did also occur inside the outer try block, but it gets caught by the closest except block. However, if this except block couldn't handle this error, but the outer one could, then it would have gotten caught by the outer one. It keeps rising and checking to see if it can be caught, and only crashes the code if it isn't caught by any of the except blocks. Now finally, here's what happens if we try to use a file that doesn't exist, fakefile.txt. Again, the code starts with line 1 and tries to run line 3, but on line 3 it encounters the error because fakefile.txt doesn't exist. So at that point, it jumps down to the except block that corresponds to this try block. It knows it corresponds because they're at the same level of indentation. It knows to skip the more indented except block. That difference in indentation means that this except block does not correspond to that try block. Then because the error arose on line 3, it skips the entire rest of that try block. It skips all the way down to the except block. At that point, because an error was encountered, it catches it, because it's an I/O error, and prints the message that an error occurred while reading the file. So if the file exists and has the right contents, the contents that our code knows how to read, then it runs with no errors. If the file exists but it doesn't contain the type of content we expect, then we get a value error when trying to convert that content to the type of data that we want, specifically when trying to convert strings into integers if the strings don't actually hold numbers. And finally, if the file doesn't exist at all, then the outer try block catches the error, then it occurs inside the outer try block, and it's caught when we catch our I/O error, and it prints that an error occurred while reading the file. Notice that while I used an else inside the inner try block, I could have also used it with the outer one. All of the code after the line that could potentially generate the I/O error could have been put inside of an else block after the except block. That makes the code a little bit cleaner to read for experts, but a little bit harder to read for novices. So we've kept it like this for now.